Hello everyone, it's July 18th. It's kind of late. I had a lot of writing done today, and writing is never my strong suit. And after lots of writing, my brain is kind of mushy. So not sure how I feel right now. So I'm going to have to also implement the strict 1 hour rule, right? So if I cannot solve it, I'll have a clear path. After an hour, I'm going to go for the solution because today, as always, we're looking at a difficult question, most likely. Oh, this is looking promising for now because it's a linked list. As you know, I like linked list. All right, let's take a look. Given a linked list, reverse the nodes of a linked list k at a time and return its modified list. Reverse the nodes of a linked list k at a time, or 2 at a time, and return its modified list. K is a positive integer and less than or equal to the length of the linked list. If the number of nodes is not a multiple of k, then left on nodes should remain as is. You may not alter the values, only nodes themselves can be changed. This might not be a difficult, might be an intermediate question. I mean, for one thing, it'll be easy to create the result, all right? I mean, we can just create a result by turning that into a list and then reverse every k items. How would you reverse every k items? Yeah, that's simple. You can finish it in O(n). So we have a clear path to get it done, but let's not do it that way. Let's do it the real way. So 1, 2, 3, 4. So every 2, so 1, 2 gonna swap, 3, 4 gonna swap. We'll leave 5 as is. 3 we're gonna swap 1, 2, 3. Leave the rest as is. Okay. Can you solve the problem in O(1) extra memory space? Well, we can first write a generic reverse, right? So we can write a generic reverse function, and I don't see how. So if it's 2, we have a front, have a left and a right. So right move k times, and then we have a front and back, and then we run a reverse. Right? When we run a reverse, that's the entire thing reverse, and we say we reorganize the 2 and then move on. I don't think this is hard though. There might be some tricks. Okay, we can start. I mean, the first thing we need to start for sure is we need to write a what I'm thinking, write a function to reverse. Okay, so we're gonna write a function to reverse. All right, how do we write a function to reverse? It has to be as generic as possible. Anyway, k, okay, let's see, size is 5,000. No value, don't really care. K is 1, okay. So we have to get this. Oh, and we don't have test cases, because I don't want to write test cases for this. Okay, so can def reverse. Actually, I prefer it here because I want. How do you reverse it? We have. Well, we need a front. We need a root. We call it root. Head and tail, right? We need a head and we need a tail, and both going to be list node. Oh, by the way, I just saw that Python 3.10 is out. I think it's out of beta. And not only that, there are a few more features added. One of them is the switch. Actually, I'm going to try pattern matching. So pattern matching has come to Python finally. This could be very useful. All right, where are we? So we have a head and tail. What we're going to return? We don't really care about the head after return, but we do care about the tail. So I think let's just return this node, just the tail. We're going to return the tail. All right, we're returning the tail. So we have a head on the tail. How do we do? We have a I remember we need two nodes. Oh man, I have to write this every single time. Like just write it out. And remember we have a dummy node, right? And we always have dummy node. Do we even need dummy node for this? So it's not going to be head tail. We're going to be dummy, head, and tail. So we have a dummy node, and we have, let's call it left and right, and pre and current, right? On pre and current, and we say temp is current on next, right? Temp is current on next, and the reverse, and point the other way. How do we point the other way? Current dot next equals pre, right? And pre equals current, current equals temp. Yeah, I think that is the way. And then temp is current on next, current on next equals pre, and then blah blah blah. When we're done, what do we do when we're done? We reverse everything. Oh, the dummy should be a none. Hold on. When we reverse the entire thing, so this goes to front, and dummy is the one that's the current one pointing to. Come on, focus. The dummy is the one that's currently pointing to, and we have dummy, and that's also head, right? That's also head. So I can just set up a dummy, and we have a point to the dummy, right? It doesn't really matter which point is the dummy, and the tail will be the new head, right? The tail will be the new head. So if we pass it in, and then we return, we have the new head and a new tail, right? We have the new head and a new tail. So let's see. We have a head, to tail, and then when we return, we have the tail pointing to the head, right? And we know the tail, and we know the head, we know these two, and what we want is for the previous one to point into the current head. So we need a previous as well, right? So we need the previous. So we have head, tail, and then we have the pre, which is pointing to the head, the original head, right? And so it's three nodes, and the pre can serve as the dummy node. If pre serves as a dummy node, then it's actually not right. Pre cannot serve as a dummy node. Then we don't care. We just internally we're gonna reverse, right? Internally we reverse. reverse to tail, blah blah blah, to head, and head will be pointed to none, right? I don't care. I have the reverse coming out. We have the tail, we have the head, which is the new head and new tail. The pre gonna point to here, and head gonna point into, oh, what is head gonna be pointing to? Ah, I see. So the dummy shall be the next head dot next. A tail dot next should be the dummy. And then it will be directly pointing to that. And then that could be the pre, and this is the next one. Okay, what's the end condition? End condition is when current is equal, so when current is not equal to tail, right? We keep going, and then current equals temp, or current equals this, temp equals current dot next, and then current dot next, because pre will have to do that, and then pre equals current. So it actually is pre, while pre is not equal to, and then comma pre is equal to, and then we break. All right, let's give it a shot. So we're gonna pass in, what should we call this one? This one we should just call it, I don't want to call it a dummy node. It should be the, we have head and tail. I'll just call it dummy node, which is something that is what we start with. I should call it dummy node. Let's call it, what should we call it? Tail next. So what tail should point into next, right? So when we do this, we want to say pre current equals tail next, right? Tail next and head. So while pre is not equal to tail, temp equals current dot next, right? And current dot next equals pre equals current equals temp. Then go back up, right? So we go this. After we end, the pre equals tail, right? Now in a return, we shall return the new head and new tail, right? So we return the new head and new tail, which means when I return, well, actually don't need to return, because the new head and the new tail would just be the reverse of the previous head and previous tail. So actually, I don't think we need to return anything. We just, yeah, I don't think we just return none. We don't have to return anything. This is just to reverse, right? We reverse the entire thing, and everything is in control, right? So here, what we need to do is we're gonna have a pre, and let's have a left and right, right? So we say we're gonna start with left, right equals head and head, right? They start on the same thing, and then we keep going, head and head, and we say, what do we say? Let's call it while true on the top. I don't know what condition will be. So if we call it while true, and we say count equals 0, right? So count equals 0. Count is how many number of steps that we move forward. And we say while count is smaller than k, right? We say right equals right dot next, right? And then count plus equal 1. So count is 0, and we move 1. Oh, count is now 0. Count start with 1. So move. So count is 1 smaller than k, and then count moves 1. Now count equals 2. 2 smaller than k, a break. So now the right is at the right position. And of course, we have to also check while right, and then we can do this, right? And when we got exit, we can say if count is equal to k, right? Count equal to k, then we're good. We have a left and right, so we're gonna call self.reverse. Okay, we talk about it. We need to have 3, right? So what we're gonna have is reverse. So the head and tail. So the head is gonna be left, the tail gonna be right. But what about the tail next? Actually, this one we should put it here. Tail next. Interesting. Tail next. So tail next is what after return. So it'll be like this is the tail next. So which is just right dot next. The tail's next, right? The tail's next. And we reverse. So the reverse will happen that the tail next is here. So this one will be pointing to tail next. That's the first one. And then this one pointing here. I just want to point in this, and I'm going to move here, and this one pointing to this, and I'm going to move in here. Then we are done. So this one will be 2, 1, 3, right? So after it's done, we'll have 2, 1, 3. Okay, so it would be 2, 1, 3 after we reverse. All right, 2, 1, 3 after we reverse. 2, 1, 3, 4, 5 is after reverse. And this will be left, this will be right, right? And then what we need to do is reassign right and then left. We both need to reassign both. So what we need to do is, if I reverse this, 3 will be pointing to 5. That's fine. But how do we make 1 pointing to 4? So we do need a pre as well. The pre. So we say a pre is going to be a dummy node. Yeah, pre is going to be a dummy node pointing to that. And they're going to start from here. They're going to reverse. After reverse, no, okay, we need a dummy. So dummy will be first. Dummy equals list node. I don't care about val. Next going to equal to head. And pre left right equals dummy head and head. Then we go, right? Then we go. Blah blah blah. And then we walk K and we do the reverse, right? Now we reverse. And after we reverse, we're gonna say pre.next equals to right. So now we reversed. And that's it. Now we're going to reassign left and right. So pre is going to be left. And left is going to be left.next. So we're moving here. Left is going to be this. And right is going to be left. Left and right will start at the same position, right? And then we go back, right? And then we go back. Else, if count come out is smaller than k, right? That means right is hitting the end. Now, when that happens, we say break, right? that happens because we have entered this situation, right? Because we said left and right both here, and then while right, and then we right move one, right? Move to okay, right is here, left is here. While right equals right on next. Ooh, I don't think it should be while right. The count is 1, right? So we should check. We always say, if count is 1 and we say the current one is valid, right? So we should check on right down next. So while right down next and count, right? Hold on. If right down next and count going back, right? And then come here, while right down next. Yeah, I think it should be right down next. While right on next, because in this situation, right on next, then we just escape. Count is 1, right? And count not equal to k, and then we just break. And return dummy.next. Alright, to be continued. I need to do more priority right now. Alright, temporarily back. Let's try it. I mean, I don't have test case, so I can run it here. So I think the first test case is a good test case because we can check, see the logic works. This one works, and of course, second one will be we add 6, run it. Runtime error. Oh, we cannot do it. Alright, we need to turn off this. How do I turn off? Let's just disable it. Yeah, I don't need it. Remove from Chrome. Just remove, and I don't want. Yeah, I don't want any. Just remove it. All right, let's solve the problem. That write down next, no attribute next. Oh, okay. So in this case, we should say while write and write down next. I mean, we're looking at is here, right? Both are here. Then so while write down next, we'll move on to this one, and while write. Okay, so while write and write on next. Make it more stringent. I think that's one will pass. Okay. How about 3? Right, let's try this. 1, 2, 3, 4, 5, and 3. 3, 4, 5, and 3. That's a good test case. 3 is good. How about 1? 1 should remain the same. Ooh. We're having reverse. Something having reverse. Okay, so if we do 1, and this is going to exit already, and count is equal to, and then left and right is pointing the same thing, and then write down next, and pre-current equals, and the head, and pre is not equal to tail. Well, pre is equal to, no, pre is not equal to tail, because pre, we set it to tail.tail next, so pre is not equal to tail, and temp is current dot next, okay, and current dot next is equal to pre. That's fine. And pre is equal to current, and current equal to temp. I think it should be fine. Alright, back at it again. We're trying to figure out why this one would be wrong. So we're trying to play this in my head. So pre is here, enter, right? Current is here, tail is this one as well. And then we say pre is not equal to tail, that's true. But pre is here, so temp equals current on next, temp is here. Current dot next equals pre, pointing to this. Pre equals current, so pre comes here, and current equals temp. Okay, so pre is here, temp is here, and then we go back. Pre is not equal to tail. Well. I don't think this one works if the head and tail are the same nodes. Because pre is, oh wait, it works. Pre is here. So pre is equal to tail, and then we exit. And after we exit, and left and right is both in here. And then pre is on the outside. Pre dot next equals right. Pre dot next equals right. Pre equals left. Left equals left dot next. Right equals left. They both come here. So that's fine. I don't see any issue with this. What is our error? Is none type has no attribute. Next. Are we just like here? Probably problem is here. Because let's just say the last one, right? The last one. We're pointing the last one. Coming in. Pre is none. Current is 5. So pre is not equal to tail. That's true. Temp equals current. On that temp is none. Current is here. Dot next equals pre. Current dot next equals pre, which is pre is none, and pre equals current. So pre comes here, and the current equals temp. Well, current is nothing, and pre is not equal to tail. Pre is equal to tail. We should exit. We should exit. Now we exit. We have pre dot next equals right. Pre equals left. Left equals left on that. I don't know. Which part is wrong? I need to see. Let's print pre dot value and current dot value. Just take a look. I don't like this type of debugging. Alright, so pre dot value, pre is 2. Current is 1, pre is 3, current is 2, pre is 5, current is 4, and with no value because pre is a none. Okay, and current is 5. That's cool. That's cool. So pre is none. Okay, pre is none. Current is if I just print out current dot val, I think it'll be just 1, 2, 3, 4, 5. Yeah, and then it says, oh, the problem is not in here. The problem is in here. Because I'm calling right on next. Left and right are both are none. So why is that? Well, it's because we're coming back up and count as 1 as equal to k. That's why. Okay, I see what the problem is. Well, I suppose suppose we can, what if we start with count equals 0? If count equals 0, and if count equals 0, and we do count plus 1 at the beginning, and then we do this, right? And come back up. If count equals 0, while this, count plus equal to 1, so we say we count 1, right? And then we go on. Now we count another 1, then we go on. And then it's equal, then you count a third one. So count 1, count 2, count is 0. And then we say while this, we count the first one and then move right to the next. Coming back up, this one counted 1. And then we're good, and move right to the next. Let's count update 2. Oh, maybe, I don't know. Is this gonna work? Like if I say count is 0? No, it's a difference. There's no difference. If count is 0, and then right goes to the next one, and then count becomes 1. Coming back up. No, count has to be 1. But we probably can like just say while right. If we do while right, I think this one will pass. Yep, I'm still printing something. Yeah, I'm still printing something. Right, because we check a while right, which means at the end, if this one doesn't break, right? If this one doesn't break, then it will break when the right goes to the end. Okay, so this one works. What else? I think it's the full. Yeah, let's say 5. And we run the complete reverse. That's a complete reverse. Last edge case, 101. If this one passes, we are going to submit it. All right, I'm going to submit it. Pending. We have got accepted. Nice. I don't think this is a hard one. This feels a medium to me. There's no trick, just straightforward. I mean, this is like a little trick. So this doesn't seem to be too difficult. How should I say it? We basically find the head and tail of each k nodes, right? For each k nodes, perform reverse on it, handle the linkage from the previous nodes to the current reversed k nodes, and move on. The edge case that caught us was when k equals 1. But actually we can actually do, if k equals 1, we just return. Right? We don't have to do anything. Yeah. But yeah, when k equals 1. We can, of course, set k equals 1 as a special case. But in the current solution, yeah, I think it should be just set it. Yeah, I like to while true, right? Then we just say if k equals 1, which means we don't do anything, we just return head. right? Yeah, the special case. I like this better. So it's very clear that the only time when it break is when we hit the end. It might run faster because we are not judging. We don't have to go through the entire. You know what? Let's use this. I think this one will be faster. So okay, the on time o1 space. All right, let's run this and see what is going to happen. Submit. I apologize. Too many walking back and forth. All right, so let's check the runtime. Not runtime, but 48 milliseconds. Okay, 48 milliseconds, which is a 79% ranking. That's as expected. And memory is here. Okay, now let's go back to the solution, which we don't have. Now, I don't think this is hard. In the 25, I've done this before. It was not hard when I first did it back in 2018, September 19th and September 20th, 2018. Those were not hard. Actually, this is slightly faster. Yeah, doesn't really matter. I don't think there's much to say about this. Old question. Fully recursive. I might take a look at that too. Traverse, reverse, reverse, K. Reverse K group. 4 minutes ago. Oh, hold on. Newest to oldest. I haven't even hot. Classic linked list. It's quite nasty. Do it on paper. Yeah, just do it on paper. We do not need to reverse last group. We only need the idea similar to problem 206. Reconnect the first and the last. Yeah, I mean, for me, it's fine. Maybe I just have a different thing with linked list. I think this one doesn't really have to. I don't really have to look too much into this. This is good enough, right? In my opinion, this is good enough. We have a reverse, which is easy to write, and all we need to do is after reverse. This is the part that we just need to figure out. Just think about it, and then we can figure out. All right, that should be it. That should be it. I was able to do it back then, but using CPP. Oh wow, that's just a different level. I cannot do CPP anymore. Point back. Oh, I think I was using recursion for this. Anyway, let's just call it. I just call it today. Call it a day. Did pretty well. But hey, this doesn't make any progress for me on solving all the problems. Right? I have a goal. Right? My goal is to solve as many problems as possible, but by having something that we solved already, it doesn't really help our case. Anyway, that'll be it for today. We got lucky. I think over the weekends, both hard questions and both solved pretty fast.